4 characteristics of polynomial functions in factored form. So we already in 3.2 went over the characteristics, right? So leading coefficient, degree, opening up, opening down, right? Roots, all that sort of, no, we're going to do roots now. So here we've done leading coefficient and degree, right? So we have odd, even, and that. What we're going to do now is add this factored form, which is going to give us this thing, which is going to give us our x-intercepts. So x-intercepts or roots or zeros. So that's the part we're going to add now. So that's the part that was missing when we had these diagrams before, is that we only have the shape, we don't have the roots. So now we're going to add the factored form. So this is different because of the factored form. We're going to use the stuff from 3.2 though. The first thing we have here is this definition says the family of polynomial functions. The family of polynomial functions is the set of polynomial functions whose equations have the same degree. So they have the same degree and whose graphs have common characteristics. So of course, if they have the same degree, they have common characteristics. So we're going to use things like, if I know it's cubic, what do I know about it, right? If I know it's a power of 4, what do I know about it? Every power of 4 has et cetera, et cetera. So we're using those characteristics. So it's not a super great definition that we need or super important. It's just that they're saying with the degree, we know certain characteristics, which is what we were talking about in 3.2. Okay? Order. Order is one that we're going to need to know. Order, we're going to use a bunch. So the order is the exponent to which each factor in the algebraic expression is raised. So this is the factor, the exponent to the factor. So like here and here. This one has an order of 2 because of the 2. Okay? This factor has an order of 1 because of the invisible 1. So the order is just the exponent. They don't say exponent, they say order. So I'll be saying the order, and I will use that language though. Okay, so they'll say this factor has an order of 3, which means just the exponent, right? So it's just a fancy way of saying exponent. All right. Use reasoning. Now it says use reasoning because for parts of this you're going to be like, I feel like this is missing something. I feel like I'm missing a bit of information. I don't quite know where something is, and you feel like there's something missing. So you're supposed to use reasoning to draw it. You know, for every polynomial function, it has to be some sort of smooth curve, right? So it's doing something like this. I don't want anything extra happening unless we're designating it to be there, right? But there should not be asymptotes. There should not be anything else happening. No holes, no gaps, okay? But there's a few other things happening, and we'll talk about that in a little bit, okay? But you're trying to use reasoning to draw it. We're going to use common characteristics from the family to draw it with the previous section, right? So we know cubes, that sort of thing, odd power, even power. Use a number line and the values in between the x-intercept. So I'll show you how that works in a little bit. So that's another way to draw it. But again, we might not use that number line too much, but it is a good method. I'll show you in a little bit how to use that. And then we're going to use x equals 0 as the y-intercept. So we're going to add this to it, to the y-intercept. I would like that to be added to all of the graphs. So far, we didn't do that. So if you think back to 3.2, you go, wait, you didn't make me do that. I didn't. We were still just getting the characteristics. But when you look back here, couldn't I have added a y-intercept here? What's the y-intercept on this? When x equals 0? 2, right? What's the y-intercept here? 0, 0, 0, negative 5. So I could have added some more information to the graph. I didn't at this point, but from now on, we'll add the y-intercept in. Right? So because it's like, it's an easy point. We know that point, so we're going to start to add that in. So I'm using that. And we're going to use the roots. Okay, here we go. There we go. So now we're going to add this to it, and we're going to use our reasoning and the characteristics that we developed from 3.2 to graph this. The first thing I would like to add, though, since it's factored form, are the x-intercepts, or the roots. So we're going to do x-intercepts. It's also called the roots, or the zeros. Okay, so it'll vary between what the teacher uses. They might say, what are the roots, what are the zeros, what are the x-intercepts? We're going to add the x-intercepts and the y-intercepts, and then some reasoning in between. Here we go. So take each one of these factors. So what's different from what we did yesterday was the other version had no factored form, right? This I'm putting it in factored form. What we're going to add to it, I think in the next section, is that I'm going to give you this form back again, and I'm going to make you factor it yourself. Ha! So this is a gift. So when it's in factored form, that's a gift to you because I factored it for you, and I'm giving you the factored form. But what I can do is I can go backwards and forwards eventually, and I will give you unfactored. You have to factor it and go back. Okay? And that will work towards that one. Not yet. Okay, so here I'm giving you the beautiful factored form, so you know where the x-intercepts or the roots or the zeros are. They all mean the same thing, roots, zeros, and x-intercepts. So over here, so I'll vary between which one I use. So I want to do, I'll say zeros then. My zeros on this one are 3, right, from this one. This one gives me -2. And this one gets me, and if you need to work it on the side, then do that. Okay, and then put that in here. Okay, I don't need to see this. Okay, you can do that on the rough paper, and some people go, you know what, I do it in my head. Am I okay? If it's a simple one, I can do my head. Yes. Okay, if you can do that in your head accurately, that's fine. If you need to do it rough, do rough, and then just give me the x-intercept. Okay, so you have your 3 zeros, or x-intercept, or roots, whatever you want to call it. Okay, so we've got those. I'm going to plot those. Okay, so plot those. I do not want you doing little tick marks. This is not accurate at all. We are just doing the shape. We're doing the shape. We're trying to get the characteristics and the shape here. It's not going to be accurate. So I just need a 3 somewhere to the right of 2/3. Doesn't have to be accurate. Don't do tick marks. We're going to get weird numbers sometimes. Okay, so just somewhere to the right of this one. And then -2 there. Okay, don't worry about the accuracy, just somewhere. All I need is 2/3 to be the left of 3, but on the right side of the y-axis. Okay, I don't care if you evenly space them, whichever. Okay, just something like that. So there you go. We got the zeros, the root, the x-intercept, whatever that's called. I need to know certain things. So I'm going to always list on the side for myself. You don't have to list this, but I like to know what the leading coefficient is. Again, that's my own short form because this is rough work. So on the side, I'm just doing a bit of rough. My leading coefficient is. So now that it's in factored form, it's a bit of a pain, but also good. It's factored, so I can get the roots. But now when you look for the leading coefficient, it's not sitting in front anymore, right? Because before it was sitting in front. Now you have to look at all the x's and at the order. These guys are all order 1, right? Order 1, order 1, order 1. So then I get 1x, another x, times a 3x. That will give me my highest degree term. X times 3x. So my leading coefficient is going to be 1 times 3, which is going to be positive. I don't need the number, just positive. The other thing I always need is the degree. The degree is x times x, order 1, right? Order 1, order 1. X times x times x, I have 3 of them, so degree 3, which is odd. Okay, it's an odd degree of 3. Okay? That tells me in my brain that it's positive and it's odd. The easiest odd is the linear, so it does something like this. So I know it's going from quadrant 3 to quadrant 1. You don't have to draw that if you don't want. Again, this is optional, but for myself, I go, okay, I know I'm down here somewhere, and I end up here in this corner. That gets me my end behaviors, right? I'm down here, end behavior, and up here, end behavior. You don't have to draw that in. I'm going to erase it after, but it gives me an idea. Okay, end behavior down here, end behavior up here. So end behaviors. Anything else? Oh, y-intercept. So let's find my y-intercept. Y-intercept is when x equals 0. Okay, so y equals, I put 0 in my head. I don't like to show this step. You can if you want. I don't need to see this step. So 3 times 0 minus 2. You can skip to here. Okay, or just give me the y-intercept. Again, some people are going, I can do more mental math now. It's up to you, but I'm going to go, I sometimes just write this. So I write something. You don't have to write the first line. I just go, that's gone, so it's -3. That's gone, so it's 2. And that's gone, so it's -2. Right? So I kind of go gone, gone, gone. So it's -3 times 2 times -2. And that gets me 12, right? Positive 12. Okay, so the x is gone, so -3, x is gone, so it's 2, 3x is gone, so it's -2, and then you can do that a bit faster. Okay, so I know that the y-intercept is somewhere down there. Now, don't plot that yet, okay? The reason why is, watch, I'm going to show you how not to do it. I think I'm going to try to do it, so it's how not to do it. So what happens sometimes is you do this, and then you plot the 12. And then what you do is you go, okay, so watch, this is what not to do. You go like this. You go, okay, I'm going to do this. And then you kind of, no, see, I did that kind of neatly. You go, okay, I went up here. Oh, wait, I got to wiggle it back down under here. And then, okay, you know what? Try not to wiggle. So see how I'm getting kind of wiggly here and kind of getting wiggly there? You can't. Uh-oh, this is really weird. You're aiming. Okay, wait, I'm trying to go through. Oh, no, what happened? So you're aiming. Take the y out for now. Don't look at that. Let's just concentrate on the roots. We'll add the y as a check at the end. Okay, you're aiming for that. So I want to go through, through, through. Okay, oh, it's true. Sorry, my 12 was supposed to be up here. Oh, sorry, it was up there. Okay, but I was aiming for that. So what ends up happening is that, sorry, do that one more time. What ends up happening is that if you put your points first, you end up aiming and you're like, so that's my maximum. I never said it was a maximum, right? And then you end up going, okay, wait, and then I'm trying. Ignore that, just do a smooth curve, and I'm going to do this, watch. Just go through, 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 through. And then come back and go, oh, look, that's where my 12 is. It never said that the 12 had to be a maximum, right? You end up tilting your graph so that it hits it like it's a maximum. It never said it was a maximum. I don't know if it is or not. We won't figure out where the maximum is until, what am I going to say? Calculus, yeah. Okay, the max we get. That's the part where you're like, I feel like I'm missing something. Where's the maximum? Pause, 5 months later. Then we'll come back and get this. That's why you feel like it's rough because you're just missing that. So I don't know if the maximum is at 12 or if it's here or if it's to this, like we don't know that shape where you're like, I feel like I'm missing something. That's what you're missing. Okay, so it's good what we're doing. We get the shape of it, but we don't know for sure. And so just draw the shape, set the 12. All I'm looking for is the general shape of this. You can erase these guys here, so it's not part of my graph anymore. But I want the general shape. Sometimes when you put the 12 or put the y-intercept, you start tilting. If you start tilting too much and you give me this, and then you give me something there, you're telling me that there's a higher degree happening. Because that means that there must be something else happening, and now you've increased your degree. This already has the maximum number of turning points, 2, right? For a degree of 3, you can't do another wiggle here. There can't be something else happening. What happens in the middle sometimes, it's called a point of inflection, where it doesn't turn, but it changes concavity. It goes concave down to concave up. So it changes, it's not a turning point, but it's a change in concavity, and then that does affect the degree. Right? But if you do an extra wiggle somewhere up here, you already have the maximum of number of turning points, which is supposed to be 2 for a degree of 3, and now you've told me something about the graph that is not true. So I'd have to circle it and go, what happened? Don't do an extra, it's not called a wiggle, it's called a point of inflection in your graph. Okay, don't go to university and say, the wiggle? No. Okay, but that point of inflection is not supposed to be happening, and if you do an extra wiggle there, I'll circle it and go, you can't. You already have your maximum number of degrees, you've now increased it, and now you're saying something wrong. So it's a rough sketch, but it also should be semi-accurate, like no extra stuff happening. Sorry, question? Yep.
Would you care if we did put a 12 as max?
No, it can go through if it naturally does, but see how mine is kind of over here and that's there? Some people do an extra, what I'm saying, that point of inflection, and you're like, oh, and then that is what I'd have to circle and go, it's not the max, it's the point of inflection where you do an extra wiggle somewhere and you're like, and I'm like, you can't. That indicates more degrees happening, which isn't happening. Okay, so yeah, it can be the max if you naturally had it kind of in between, but don't do an extra, tilt and stuff. That's the problem. Okay? Naturally, if it was, that's fine. It could be, it might not be, who knows, right? We find that out later on in a few months. Okay? So that's why I say sometimes just put the y-intercept later. The nice thing about the y-intercept, it also is a good check. It should be at positive 12. If it's not at positive 12, then you go, wait, one of these things is wrong. Either my graph is facing the wrong way, right? So you know how I was drawing it wrong here? And it was like, wait, what happened? I had an extra root. Oh, my y-intercept is wrong. So something's wrong. So this is a nice check for me at the end. I go 12, yes, it hits at somewhere, maybe at 12. And then if you had negative 12, like I had at the beginning, you go, wait, something's wrong, either with my negative or with my graph. Right? So use that as kind of a check. I do want it included, but kind of go, oh, wait, does that make sense or not? Good? Okay, I'm going to pause the...